Section C, Internet and Communication Technologies. Question 4, Theory. For questions 4.1 to 4.5, you need to select the most correct answer from the options A to D. The answer grid is at the bottom of this page for your answers. You merely need to write down the appropriate letter for your answers. This is what we're going to do. We're going to choose the correct option and we're going to discuss why the other options are not correct. Question 4.1. DHCP is a protocol used to set up transmission security. That's A, which is wrong. DHCP is a protocol used to allocate IP addresses to devices. That is B, and it is correct. DHCP stands for Dynamic Host Configuration Protocol. It is a network protocol that automatically assigns IP addresses and other network settings to devices on a network. The other options are incorrect because letter A, DHCP is not a protocol used to set up transmission security. That would be protocols like SSL or TLS or IPsec. Letter C is not correct because DHCP is not a protocol specifically designed for mobile networks. While DHCP can be used on mobile networks, it's not its primary purpose. Letter D is not correct because DHCP is not a protocol used to link URL and IP addresses. That would be the Domain Name System, DNS protocol, which translates domain names to IP addresses. Now, here's how DHCP works. It connects a device to the network. The device sends a request to the DHCP server asking it for an IP address and other network settings. The DHCP server assigns an available IP address and other settings such as subnet mask, default gateway, and DNS server addresses to the device. The device uses the assigned IP address and settings to communicate on the network. Now obviously we understand the importance of an IP address. In order for a device which is downloading a video or generally communicating over a network, it is important to have an IP address because it tells the network where your location is. In this way, whatever you request will be sent directly to your device. So that leaves the question. Is it true that every single time a device connects to a different network, it receives a new IP address? When a device connects to a different network, it typically receives a new IP address from the network's DHCP server. This is because each network has its own pool of available IP addresses and the device needs to be assigned an IP address that is valid on that specific network. Here are some scenarios where a device might receive a new IP address. The first one is switching between Wi-Fi networks. The second one is changing Internet Service Provider, ISPs. The third one is traveling to another location, and the last one in this example is restarting your router. If you restart your router, you might receive a new IP address from the ISP's DHCP server, depending on the ISP's configuration. There are cases where devices retain their IP addresses. This is known as static IP address. If a device is configured with a static IP address, it will retain that IP address even if it connects to a different network. The second one is mobile networks. Mobile networks often retain their IP address when switching between different cellular networks, as the IP address is assigned by the mobile network operator. Let us move on. Question 4.2. Thin clients. Letter A. Thin clients are only used on cable networks. Not necessarily. Letter B. Thin clients are used to reduce server processing requirements. False. Letter C. Thin clients are devices with minimal processing ability. True. Now let us discuss why the other options are incorrect. We will start by defining what thin clients are. Thin clients are lightweight computers that rely on central server for processing and storage. They have minimal processing power, memory, and storage and are designed to provide basic functionality such as accessing applications, browsing the internet, and running simple tasks. The other options are incorrect because thin clients can be used on both cabled and wireless networks. Letter B. Thin clients actually increase server processing requirements as the server handles most of the processing and storage tasks. Letter D. While thin clients can be used in school networks, they are not commonly used in most school networks. However, they may be used in specific situations, such as in computer labs and libraries, where users need to access specific applications or data. 4.3. MAC addresses. Letter A. MAC addresses uniquely identify network cards. True. Completely true. Let us go to the definition of MAC addresses. MAC, standing for Media Access Control. MAC addresses are unique identifiers assigned to network interface controllers or network cards. They are used to identify a device at the data link layer of the OSI model. B. While MAC addresses do identify devices on a network, they specifically identify the network card, not the node or the device itself. Letter C. MAC addresses do not identify switch ports. Switch ports are identified by the port numbers. Letter D. MAC addresses do uniquely identify network cards, so this option is incorrect. Note, it's worth noting that MAC addresses can be spoofed or changed, but this is not a common practice and is usually done for specific security or testing purposes. 4.4. Ethernet. Ethernet is a commonly used LAN protocol. True. Letter B. Ethernet uses ARP, Address Resolution Protocol, to identify devices. True. Letter C. Ethernet allows for different transmission speeds on the same network. True. The most correct answer is letter D, all of the above. Now let us explain. Letter A. Ethernet is indeed a commonly used LAN protocol. It's a popular choice for building local area networks and is widely used in homes, offices, and data centers. Letter B. Ethernet uses ARP, Address Resolution Protocol, to identify devices on a network. ARP is a protocol that maps IP addresses to MAC addresses, allowing devices to communicate with each other. Letter C. Ethernet allows for different transmission speeds on the same network. Ethernet networks can operate at various speeds, such as fast Ethernet, which is 100 megabytes per second, gigabit Ethernet, which is 1000 megabytes per second, 10 gigabit Ethernet, which is 10,000 megabytes per second, 40 gigabit Ethernet, which is 40,000 megabytes per second, and 100 gigabit Ethernet, which is 100,000 megabits per second. Ethernet networks can also use auto-negotiation to automatically adjust the transmission speed to the higher speed supported by both devices. 4.5. Video on demand. Letter A. Video on demand can only be offered on a cabled network. Not necessarily true. Letter B. Video on demand eliminates the constraint of static broadcast schedules. True. Now let us discuss what video on demand is and does. Video on demand is a service that allows users to select and watch video content at any time, rather than being tied to a traditional broadcasting schedule. VOD eliminates the constraint of static broadcast schedule by allowing users to watch content at any time rather than a fixed broadcast time, enabling users to pause, rewind, and fast-forward content, giving them more control over their viewing experience. Providing a wide range of content options, including movies, TV shows, and original content. VOD can be delivered over various networks, including cable networks, fiber optic networks, satellite networks, internet protocol television networks, and over-the-top streaming services. Now, the other options are incorrect because A. VOD can be offered on various types of networks, not just cabled networks. Letter C. VOD can use various protocols for transmissions, including TCP, UDP, and HTTP. The choice of protocol depends on the specific implementation and requirement of the VOD service. Letter D is incorrect because VOD is not usually offered as a free service. While some VOD services may offer free content or trials, many require a subscription or rental fee to access premium content. VOD has revolutionized the way people consume video content, providing more flexibility and control over their viewing experiences. Its popularity has led to the growth of streaming services and changed the way content is created, distributed, and consumed. Now this may raise the question. OTT stands for over the top. In the context of video streaming, OTT refers to the delivery of video content over the internet, bypassing traditional broadcast and cable television platforms. OTT services allow users to stream video content directly to their devices, such as smartphones. This is how we are able to watch anime. Smartphones, Tablets, smart TVs, streaming devices, and gaming consoles are common examples. 4.6. Two techniques used to compress data are lossy and lossless compression. 4.6.1. For each of the characteristics listed above, you must indicate whether each applies to lossy or lossless compression. You need to tick the appropriate box. Before we begin, let us take a quick look through this beautiful illustration at the left of our screen. We see from the image that there are three general types of compressions: lossy, glossy, and lossless, but we're asked to focus on mainly lossy and lossless. Lossy compressions compresses files significantly, from 6.9 megabytes down to 0.5 megabyte in this example, and lossless compresses only 3%, from 6.9 megabytes to 6.7 megabyte. Now, the definitions. Lossy compression. Lossy compression reduces the size of data by discarding some of the data, which can lead to a loss of quality. This technique is commonly used for compressing multimedia data such as images, audio, and video. Examples of lossy compression algorithm include JPEG, Joint Photographic Export Group for images, MP3, MPEG Audio Layer 3, MPEG, Moving Picture Export Group for video. Lossy compressions work by removing redundant or unnecessary data, approximating data using mathematical models, discarding data that is less important for human perception. Now, lossless compression, on the other hand, reduces the size of data without discarding any of the data, preserving the original quality. This technique is commonly used for compressing text, executable files, and data that requires precise preservation. Examples of lossless compression algorithm include zip, zip file format, gzip, GNU zip, PNG, portable network graphics for images. Lossless compression works by identifying and removing redundant data, representing data using more efficient encoding schemes, using statistical models to predict and encode data. The key differences between lossy and lossless compressions are as follows. Lossy compression sacrifices some data to achieve smaller size files, while lossless compression preserves all data. Lossy compressions is typically used for multimedia data, while lossless compressions is used for data that requires precise preservation. In summary, lossy compressions are suitable for applications where some data loss is acceptable, such as images and audio compression, while lossless compressions is necessary for applications where data integrity is crucial, such as text and executable files. Now the answer. 4.6.1. Letter A. Characteristic. Removes as much data as possible from the original file. Quickly take a look and answer it yourself. Then we'll move on to 4.6.2. Here are the answers. 4.6.2. For two of the three characteristics above, explain why you chose lossy or lossless compression. Name the characteristic and then write your explanation. Circle the characteristic letter A, B, or C. I circled letter A. Lossy. The more data removed from the file, the smaller the file becomes. Characteristic 2. Lossless. The original quality of the data must be maintained. Thus, little data will be lost. As a result, little space will be made.